So what is the difference between cross multiplying or canceling, and how do you solve algebraic proportions? Well, the answer is cross multiplying, so stay tuned. Hey sports fans, welcome to Planet Numeracy. If we're just meeting, my name's Mark Nolde, and I've been teaching high school and college math students for over 20 years now, and that includes my 4 daughters. So here we go. So today I have a couple of examples to show on algebraic, using cross multiplication to solve algebraic expressions. So what makes this algebraic is this x right here. So the reason we know, going back, the reason we know, say, that 1/2 is equal to 2/4 is because if I typed it in a calculator, it's one way to tell, I'd have 0.5 equals 0.5. The other thing is that the cross products, 2 times 2 equals 4, and 1 times 4 equals 4. So when these two cross products are the same, that means that these two fractions are equivalent. And two equivalent fractions forms what we call a proportion. So proportion. So now we have one that we're trying to figure out, what is this x variable? So if this is a proportion, it says they're equal to one another. That means that 15 times 2 must equal 3 times x. So I can write that equivalent equation like this. 3x equals 30, because 15 times 2, that's my 30. That's where the 30 is coming from. Then, to solve this equation, I'm just going to divide both sides by 3. Easy enough to do. 3 divided by 3 is 1, and 30 divided by 3 is 10. So there is an example, a very easy example to show. Now, sometimes one of the reasons people might say, hey, why do I have to use cross multiplication? Can't I just recognize that to go from right to left, that's like multiplying by 5. Couldn't I have done the same thing here? And the answer is yes, absolutely could have. 2 times 5 is our 10. But where it comes in handy is, let's suppose we had one that looks like this. This is still easy because we can cross multiply to solve it. But suppose that we have x over, say, 6 equals 3 over 9. All right, so this is a little bit more challenging. What do we multiply 6 by to get 9? Or what do we multiply it by? It's actually 1.5, or 1/2, I guess. 1.5. 6 times 1.5 is 9. All right, but maybe we're not super up to date on multiplying by decimals, so we could then go ahead and say, well, I'm going to go ahead and cross multiply this. I have 9 times x, which I'll write here, and that's got to be equal to, let's see, we'll go blue, 3 times 9. And 3 times 9 is 18. So now if I just divide both sides by 9, I can get that x was equal to 2. So without knowing this, this cross multiplying may be a little bit easier. But both methods work. So let's go on to one that's a little bit more challenging. So here's one that is, we'll call it medium. So the reason being is I now have a binomial term, okay, binomial numerator here, but there's an equal sign here which tells me this is a proportion, which means this fraction is equal to this fraction. If that's the case, then their cross products must also be the same. So let's go ahead and do that. What is, I'll have 10 times x minus 2. So I'm going to end up having to distribute this, and then we'll go, let's go red. That's equal to 40. Okay, 8 times 5 is 40. So a couple of ways that we can go about doing this. I've seen students do this both ways. All right, way number 1 is to distribute this 10. And we'd have 10x minus 20 equals 40. And then add 10x on each side. I'm sorry, add 20 on each side. 40 plus 20 equals, 40 plus 20 is 60. And then divide both sides by 10. So divide by 10 here, divide by 10 here. to get x equals 6. So that's one way of doing these. Another way of doing these that some students like is to take our 10 times x minus 2, and it's equal to 40. Some students will do this first, and this will work just fine. They'll divide both sides by 10, and the reason they do that is to get these two 10s to divide out. So now we just have, we'll go into our next equation, is x minus 2 equals 4, because 40 divided by 10 is 4. Then I will add 2 on each side. 4 plus 2 is 6. So notice we get the same answer in both cases, just two different ways to do that, right? Or as they said in the old days, there's more than one way to skin a cat. So this one is maybe hard because it's a word problem. It says the ratio of boys to girls is 3 to 2. The class has 25 students in all. How many boys and how many girls are in the class? So this could be set up one of two ways. In the beginning, students will set it up with a ratio box, using a ratio box. So they'll have a ratio and an actual. And I've shown this in videos before, but it's a very good way. So we have, let's see, boys to girls and T for total. So the ratio of boys to girls is 3 to 2. So 3 plus 2 is 5. And then over here, it says we have 25 students total in the class. So that would go in this column. And we want to know how many boys and how many girls are there. So these are both ratios. So a couple of ways to think about this now. One of my favorite ways is to recognize the scalar multiple of 5. If I just multiply by 5, I'm going to go from 5 to 25. Well, the same thing can be said of the 2. 2 times 5 equals 10. And 3 times 5 is equal to 15. And then 15 and 10 do indeed add up to 25. So if you're just new, just getting started out with these, this is one of the best ways to set this up. If you want to set it up algebraically, some students will do that too, right? They'll say 3 is to 5 as, let's see, 3 boys. Yes, 3 is to 5 as how many boys is to 25. Again, two different things we could do. We could cross multiply, and we'd have 5b is equal to 75, or b is equal to 15. So that's another way of doing it. The other thing some students may notice is when I set it up like this, I still notice that I have a scalar multiple of 5. So if I'm multiplying by 5 to go from 5 to 25, multiplying by 5 would figure out how many boys there are. And you could do the same thing with the girl equation too. You could say, all right, 2 girls is to 5 total is how many girls is to 25 total. And again, scalar multiple of 5. So we could just multiply by 5 here and say that G is equal to 10. Or, if you like, you may cross multiply. So I have a 5G here and a 25 times 2, or 50 here. So if 5G equals 50, then G equals 10. So two different ways to look at that. So for my money, if you're just starting out, I like the ratio box, right, this way right here. So maybe you're in 7th grade, 8th grade, just getting started out with these, and, sometimes we all struggle with word problems when we were younger, so it's a good way to set it up like this. Okay, so solving proportions also show up sometimes in geometry. So when you go from algebra to geometry, and you get a problem like this, it says in this diagram, got 2 triangles, triangle ABC, that's our yellow triangle, and triangle XYZ, that's our blue triangle, are similar triangles. What is the value of n? So this is what we're looking for, n. So ABC, X, Y, Z. So we know which pieces are congruent, or not which are congruent, similar, but corresponding. So this 4 corresponds to this n, and this 7 corresponds to this 10. So I could say 4 over n equals 7 over 10. That is one way to do this. And then I would cross multiply, and I'd have 7n equals 40, or n equals 40 sevenths. Or I guess if you like mixed numbers, you could say that's 5 and 5 sevenths, whatever it is. The other way, if anybody sees it, you see another way to set this up? I could have gone this way. I could have said n over 10 is equal to 4 over 7. But notice when we cross multiply, we're still going to have 7n equals 40, right? So we would have n equals 40 sevenths. And 7 goes into 40 5 times with a remainder of 5. So if you prefer, go ahead and use mixed numbers, or your calculator will do this for you as well. All right, so good job today. Hopefully you got some value out of this. So hopefully you liked that little micro lesson on cross multiplying. It's a very useful skill used in solving proportions, word problems, and even in geometry. So what is one of the things that causes you to slip up in class? Let me know in the comments down below. And don't forget, please, to give this video a like and subscribe to the channel. Helps the YouTube algorithm. And always remember that math is not a spectator sport. It's a participation sport. You have to do math in order to get good at math. So make sure you're paying attention in class and doing those assignments that your instructor is giving you. Until next time, this is Mark Nolde signing out.